Well, let's go ahead and get started. And my job is just to make sure I introduce Dave. You all know him as the commander of SPAWAR. I know him as one great engineering duty officer who's been an advocate of ASNE for a very long time. But what I like about what Dave has brought to the business of cyber is that unflinchingness that you get when you are a shipbuilder and have to stand up to the CEO of billion-dollar companies and say, this is how it's going to be. He's brought that whole ethos, the comfort of talking to industry and just saying, this is where we're going and I'm going to take you there. And I think that's been very, very important for moving cyber, the awareness, the protection business mainstream, and particularly the IT technical authority. So Dave, I'm going to turn it over to you, let you have the panel, and thank you for your work in moving in that direction.
Thank you, appreciate it. Well, good morning, everybody. I would take this as the spearhead of the emerging ASNE cyber community. So welcome to the A team, okay? Would have liked to have a few more people, but that's fine. You can tell everybody else what they missed, okay? So we have a very good panel here of a cross-section of cybersecurity experts. As I mentioned earlier, I asked them to focus on control systems, engineering, mechanical-y kind of things on purpose, recognizing the audience. I'll go through and introduce everybody. A couple of them have briefs, a couple of them are talking, so we'll sync the displays as we step through that. And I have a short opening monologue, if you will, on hacking your car. So without further ado, first speaker will be Victor Gavin, Program Executive Officer, PO Enterprise Information Systems. Vic Gavin took charge of POEIS in 2012 and oversees a $2 billion portfolio of key programs for the Navy, including NMCI, Navy Enterprise Resource Planning, Global Combat Support System, Marine Corps, Sea Warrior, Security Cooperation Enterprise Solution, and Enterprise Software Licensing, as well as Navy ERP. Vic's prior assignments include Deputy PO for Littoral and Mine Warfare, Technical Director for PO Submarines, and a number of engineering and acquisition-related positions. Thank you, Vic, for agreeing to speak. Next is Mike Spencer, works for me, Deputy Chief Engineer at SPAWAR. Mike was selected to serve as SPAWAR Deputy Chief Engineer in 2009. He provides technical direction and oversight of all SPAWAR engineering efforts, ensuring timely delivery of interoperable, affordable, and supportable SPAWAR systems and services. Mike's prior assignments include Director of Operations and Deputy Executive Director for Joint PEO Jitters and Program Manager for PMW 150 Command and Control Programs. He's also served a number of previous positions within the systems engineering and software development fields. Next, a real catch, Steve Oren, Chief Technologist, Intel Federal, Intel Corporation. Steve Oren is Chief Technologist for Intel Corporation's Federal Division and is responsible for cybersecurity and cloud strategy, architecture, and engagements. Steve has held architectural leadership positions at Intel, where he has led strategy and projects on identity, anti-malware, cloud, virtualization security, and is the creator of Trusted Compute Pool's secure cloud architecture. Steve is a 20-plus year veteran of the security industry, holding CTO and CSO positions at several successful startups. He is a recognized expert and frequent lecturer on enterprise security and was named one of InfoWorld's top 25 CTOs of 2004, and in 2009 was named a fellow at the Center of Advanced Defense Studies. Steve is a member of AFCEA, ISACA, IACR, and is co-founder and officer of Web Application Security Consortium. Thanks, Steve, for agreeing to come here today. And last but certainly not least, Dr. Marv Langston, bringing 34 years of public service and 12 years of private sector experience to our panel. I'll just highlight a few of his assignments. He spent 22 years in the Navy working on nuclear submarines and acquisition programs. He would go on to serve in the government at the Defense Advanced Research Projects Agency as the Navy's first CIO, and finally as Department of Defense Deputy Chief Information Officer. In the private sector, Dr. Langston has held positions of COO and CTO for small and large businesses, respectively, and currently provides consulting services for leadership, enterprise architecture, engineering project management, and organizational strategy. So what you see here is more Navy, more industry, and then more cross-cutting across all of the above. So I'll start out with my monologue. I promised you I'd talk about hacking cars. A couple of very good articles. SPAWAR website has some. 60 Minutes did a nice show, and as I've been learning, there are some material available on the internet on hacking cars. And the reason it's, I think, significant to talk about it is a car is a network. A modern car will have 400,000 or 500,000 lines of code, 20 or 30 processors, and potentially it uses an industry standard network. Most of them do. And as I mentioned this morning, they maximize the user experience. I think that's the correct marketing term. So your phone and your stereo and your CD, you can plug your iPod in, your Samsung, it's got an automated wireless locking system, you can do Bluetooth, and that's all great to maximize the user experience. However, it also maximizes the ability to get into the system. So a couple of professors from San Diego, or UC San Diego and University of Washington, got a couple of their smart students together, bought a couple of cars, and went to town. Here's the abstract of the article. Modern automobiles are no longer mere mechanical devices. They are pervasively monitored and controlled by dozens of digital computers coordinated via internal vehicular networks. While this transformation has driven major advancements in efficiency and safety, it has also introduced a range of new potential risks. In this paper, we experimentally evaluate these issues in a modern automobile and demonstrate the fragility of the underlying system structure. We demonstrate that an attacker who is able to infiltrate virtually any electronic control unit, ECU, can leverage this ability to completely circumvent a broad range of safety-critical systems. Over a range of experiments, both in the lab and in road tests, we demonstrate the ability to adversarially control a wide range of automotive functions and completely ignore driver input, including disabling the brakes, selectively braking individual wheels on demand, stopping the engine, and so on. We find that it is possible to bypass rudimentary network security precautions within the car, such as maliciously bridging between our car's two internal subnets. We also present composite attacks that leverage individual weaknesses, including an attack that embeds malicious code in a car's telematics unit, and that will completely erase any evidence of its presence after a crash. Looking forward, we discuss the complex challenges in addressing these vulnerabilities while considering the existing automotive ecosystem. So that's what you drive in every day. It's starting to be hit the press a little bit. Like I said, 60 Minutes did a nice piece on it about a month ago, I guess. And the reason I'm bringing it up is that I think is representative of some other systems we might be able to think of. So, Vic, over to you. Thank you.
Well, good morning, ASNE. How are you this morning? Great. I am so excited to be here. For me, as you heard from my background, this is old home day for me. The vast majority of my career, I spent coming to this event, working submarines, working shipbuilding, and that is certainly the foundation that it has made me. But over the last 3 years, however, I've had the unique opportunity to serve as the department's acquisition lead for shore-based IT. So in doing so, I just want to spend a little bit of time today, and the Admiral wants to talk about ship side, but I want to talk just a little about some of the challenges I see that the department, and I'll say by and large the federal government is having in acquiring IT, and specifically in our role in cyber. And I'll say these are just simply observations, and I want to put this out here to kind of have you guys help me think it through, help us all think through how we improve some of these situations. So the first of these challenges, I'll say, I'll make it real simple. We as program managers in our day to figure out what's important to the government, there was one technique I used to use, and that is simply follow the money. So if you think about cyber from that perspective, you say, well, is cyber a Navy problem? Is cyber a military problem? I contend that cyber right now, from a cybersecurity standpoint, that is a national problem. And if we take a hard look at where the money is that is going into cyber, I read an article recently that said there were 3 companies, if I recall, Google, Amazon, I forget the third. They're investing up to $18 billion. They invested $18 billion into cybersecurity last year. And that investment was more than the entire federal government combined. So if you simply follow the money, to me, it begs the question is, well, the government has a choice. Do we want to take over the resourcing of that, or do we work on a different relationship with those industry partners by which to enhance our requirements, to address our unique applications to cyber. And what does that relationship look like? Unlike those that are out there in the shipbuilding world, again, I work submarines, and all of the R&D that went into submarines came from O&R. All of the research and development dollars came from those things, and all the techniques, all the procedures came from investments from the Department of Navy. I contend in the cyber world that is a shared investment now, and as a result, our relationships with those other entities, both federal and defense, have to be united in trying to resolve this problem. The second challenge I see going across it is educating our people. Again, this is a fast-changing world. We're working in the submarine world and the LCS world. We talk a lot about 30-year shipbuilding plans. We build a lot of our designs based on a 30-year life cycle of our equipment. Well, in the cyber world, in the IT world, that life cycle itself is defined within the FIDP. Within the 5-year development plan is a complete life cycle of IT. So what does that mean to how we invest? What does that mean to how we plan our technology changes, how we plan and resource those things that are necessary? How do we educate our folks to be prepared for that? We've done a couple things inside of my PEO. My major program manager, Captain Mike Abreu, the Navy has a fellows program, industry fellows program. And Mike had the opportunity to spend a year working at Google. Understanding, not trying to rebuild the internet, but understanding the techniques, understanding the processes they use to deliver the service that they provide to all of us on a daily basis. And we've leveraged quite a bit of that knowledge to bring back into the services we try to provide to the Navy. I contend we need more relationships like that. We need to interface better with industry on both sides. I need to have a more open ear to have people, I'll say, that we have ready access to, again, separating the true acquisition from the technical knowledge, as well as putting people in your environment to understand our unique challenges, especially on the shipbuilding side. On the shore side, I'm pretty much like a lot of the industry. But ships are very unique in how they use and access the network. And some of those unique challenges, we need to be able to articulate back to those smart, young, 25-year-old, long-haired guys to get them to think about the solutions to those things. So those relationships, that business relationship, I think we need to challenge ourselves to improve. And the third and final thing I'm going to talk just a bit about is the acquisition process. Now, I contend from a DoD perspective, our acquisition process is a wonderful process when it comes to buying those huge 30-year-old ships. but we are truly challenged, as I said, in something that changes as rapidly as it does. The idea of coming up with the detailed requirements, the length of time it comes to get with detailed requirements, CPDs, CDDs, palming for those things, in a window where the technology has a life cycle of about 5 years, it doesn't necessarily fit. So we have some very unique challenges to articulate and put budgets in place to respond very rapidly, not to the technology changes, but also to the cyber threat. The cyber threat changes daily. So our ability to work inside a existing year with those existing budgets, our ability to plan for that becomes very challenging. And our ability to defend a budget that says, this money is here in case, it's not necessarily in case, but when something happens and I have to respond to that. So what we're trying to do on our side is we're trying to put together some unique processes by which we can, first of all, rapidly change the network. And as I said, I'm a creature of habit. I worked very closely on the combat systems side on a program called ARCI, the ARCI APB process. And for those that are familiar with out there, I see a couple of heads nodding, we were very successful a few years ago in getting new capability in the hands of the sailors on an annual basis. That's where we started. And what we found after a few years, well, in some cases, that's almost too fast to keep up with the training requirements, so we slowed it down a little. But what we proved in that process was that, hey, the acquisition process can flex to do this. We complained about CPDs, we complain about it, but we've proven that there is enough flexibility if we know how to ask for it to respond rapidly. But we have to educate our PMs. We have to educate our acquisition workforce to take advantage of those type things. And we're in the process of doing exactly that right now on the shore-based acquisition side. And we're setting up a process, again, mirroring the APB process that we're calling the innovation cell. And I'll make it real simple for you. For those that know the APB process, take that documentation, change the name, you got it. You understand exactly what we're trying to do, and we're trying to take those applications, those new techniques, and insert them into our network, that be an NMCI engine, into our applications, whether they be in-one portfolio type applications or ERP type applications. That exact same process will feed a lot of the innovations that are going into our acquisition program. So we look forward to those, to you guys' participation in that. We have our first industry day scheduled for March 26th. For those that may be interested in coming and hearing what those first industry challenges are that we want to put out there for you to bid on. So with that, I thank you for allowing me to say a few words here today, and turn the mic over to Mr. Spencer.
And so actually,
Wait a minute, not actually, we're going to jump over you.
Oh,
'cause
yes.
We have a C4I problem.
Yeah.
So, Steve, if you wouldn't mind picking up, and then we'll come back to Mike in
Sure.
a minute. So we're real privileged to have you here. Thank you very much for coming.
Thank you. Okay, so we get the first slide up. They're working on it. So while they're working on that, getting the first slide up, what I thought I'd talk to you a little bit about today is sort of, start off with a little bit of the doom and gloom. There we go. So, wanted to talk about what 2014 looked like, and a lot of analysts at the end of the year really coined this term that 2014 was the year of the data breach. So just from a raising of hands out there, how many of you heard about the Target attack, or the Sony attack, or the Home Depot attack? Great, so we're all watching the news. 2014, it didn't seem like we went a month without some major attack happening. What was interesting about them was the scale, the scope, the methodology, and in some cases the reasons, or the why they attacked the companies. The classic example we've seen over a number of years, it was always profit motivated, really for the past 10 some odd years. Steal credit card information, then use the credit cards to do identity theft, to do fraud. And that's a running theme that's been around for some time now, which was a change in the early 2000s from the mischief motivation of just sort of hacking to see what would happen. We really started to see a business form in the dark web, and a business form around how do you take advantage of the assets you've stolen. And that theme continues. So the Home Depot attack, the Target attack, Anthem, these are examples of where the cybercrime was about trying to get information that they can use to make money. What was interesting about 2014 is that we saw some very public attacks that had nothing to do with financial motivations. Matter of fact, the data they stole immediately got posted to the net. The one that most people have heard about was Sony. Whether or not it was in response to a B-class movie or not doesn't matter. The fact is that hackers got in, stole data, IP, everything up until including the emails of the CEO, the network admin's passwords and personal information, and posted it all to the net in a succession. It was a slash and burn kind of approach of really doing damage to a company for a non-monetary purpose. What was also interesting around the same time, and it sort of got lost in the shuffle because it was around the holidays, and so there were lots of news about that, and Sony was still in the news, was that Sands also got attacked. And for those not familiar with Sands, that's the Sands hotels and casinos. And their systems were attacked, very targeted around certain hotels and certain properties around the world. And it was a response to something the CEO said, so it was again, not a financial motive. They published the information online of what they stole, so information about all the employees, players, information. But one of the other interesting things is unlike Sony, which was really about doing the attack, publishing it, and doing as much damage as they could to that data, the Sands attack when it was done, they did a slash and burn of what we call a permanent denial of service attack. So they went after the firmware and BIOS of the systems that they would stole information from to shut them down, which meant that recovery of those systems was really hard. We really had to either send the box in to be refurbished or buy new systems. So it was a slash and burn approach with a physical denial of service attack at the end, which is really interesting in that we known about this capability, but we really hadn't seen it deployed in the public space yet. One of the other things to take a look at when we look at the kinds of threats that we've seen over the last couple of years is how they're getting in. And the classic model of phishing somebody, of sort of sending an email to an employee and trying to get them to click on a link still works. We see that happen. But one of the interesting things, and I'll pick on a couple like the Target attack or the Home Depot attack, is what we call an asymmetric attack. They went after something small in order to get something large. So some folks may have heard that the Target attack started through the HVAC systems and through a company that was managing the HVAC systems. So in this case, they were targeting an IoT or an Internet of Thing kind of device and a control system, not with the intention of attacking that system, but of using it as the launch pad to get to the networks that it connects to. And so by coming in through the HVAC systems, they were able to then get into the corporate network. And then we, of course, we can sit here and opine about whether it was smart to have those systems connected to each other, probably not. But we'll let the analysts figure that one out. But at the end of the day, how many of your connected systems do have to talk to a network at some point, either to provide data and telemetry for maintenance requirements, logistics environment, to be able to get new parts out or do replacements, or be able to, in many home environments and in smart buildings, just be able to control the temperature. So wouldn't it be, you see these really cool apps of, well, I can turn down the air conditioning from my phone. Well, that means that there's a command going from your phone to some network to the device. And so if they can get into the device, they can get back into your phone or into that network. So this asymmetric methodology is something we're seeing as a continuous trend. So again, Target was a really publicized one. We've seen some smaller examples. But then we look at something like Home Depot. And in the Home Depot attack, they use the point of sale of device as the target. And so that's the little thing you swipe your credit card on, and they attack the firmware of that device with malware and use that as the mechanism to help start the process of stealing information. So once again, a non-user device, it wasn't a phishing email, it was a mechanism of getting their malware or their virus onto a device that doesn't have the same level of due diligence, and in many cases doesn't have antivirus or other tools that you would typically use on your laptops. So those are some of the big public attacks. And one of the other things I wanted to talk about on the doom and gloom side before we get to, okay, how do we solve these problems, is that the trends that we're seeing going forward is an increased focus on these asymmetric styles of attacks, going after sort of the Internet of Things devices, cars, airplanes, and other systems to do havoc, to steal data, or to demonstrate that they have the power to do so. A couple of interesting examples. The Admiral mentioned the one about the cars. There's some really good videos online if you want to go check them out about people hacking cars and what happens when you don't get the bits right and they drive in reverse when you want to drive forward and vice versa. But also I think it's interesting to note that even our industrial control systems themselves are potentially vulnerable. If you want to go look up something really interesting, go to the Idaho National Labs. There's a video of them using a web attack to put a power generator just slightly out of cycle. And of course, when you put a power generator just out of cycle, it starts to shake and eventually blows up. So here we have a web-based attack causing real-world physical damage. And so this is a recurring theme where we're going to see more of going forward in 2015 and 2016, as well as and if you look at the research papers out there and the ones that were mentioned, as well as others, there's a continued focus on what we call firmware or BIOS level of the attacks. So the OS and the web applications, of course, they're still rich targets. But from a threat agent or a bad actor's perspective, I want to be able to get deep and get persistent. And to do that, I want to go after firmware and BIOS. And that means attacking the lower level parts of the system running underneath the OS. And there's an increased focus in both the research community as well as in some new exploits we're seeing into these deep, low-level attacks that are underneath the purview of most of the security software out there. So how did we get here? Really, it comes down to a nasty math problem. And that math problem is, if you go back 10 years, we maybe had 1 billion connected devices. And what's interesting is that there was lots of predictions that we'd have 15 billion connected devices by this year. If we look at the end of this year, the trends are looking, we're going to beat that number. And if you project out just another 5 years, we're going to expand to almost 100 billion connected devices. And that's everything from the phones in your pockets, to your normal laptops, to your car, to your house, to your refrigerator, to a variety of other devices. And of course, when you start thinking about the kinds of systems that we're deploying in the Navy, those all connect to something. These are all connected devices. They may be what we call headless devices, in that there's no UI, there's not a pretty GUI with windows that you can move around, but they're still talking to something. They're delivering data to something. And that, if they're delivering data to something, there's a potential for someone to deliver data to it. At the same time, we're seeing budgets either being kept solid, kept flat, or declining. We're seeing really a challenge around the resources. I know this is a topic that's being talked about a lot here at this event, is how do we train that next generation and keep them up to date with the newer technologies? And at the same time, we're also in the constant thrash of, well, do I try to secure the system, or do I go after getting the right checkboxes to be able to make sure I'm in compliance? And of course, you have to do both, but how do you balance your time to be able to deal with the incoming threats? And there's some other numbers here that I provide to you about just sort of how the threats continue to be a significant challenge. Almost 470,000 unique new malware samplers are identified every week. That is an incredible number. If you go back just 10 years, that was a yearly total. So we have now gotten to the same that we had about 10 years ago in a year we get in a week as far as new malware samples. At the same time, and this is from a couple different studies, and one that McAfee and Intel did together, we got these numbers, but you'll see similar numbers from a variety of other analysts. On average, about 83% of Fortune 1000 companies were affected by an APT last year. Whether it's 75%, 85%, it's all within that range depending on who you ask. And so what we're seeing is these really advanced malware attacks are getting pervasive. So enough with the doom and gloom. How do we solve this problem? So the path forward is really to start to look at an end-to-end security model. And it starts with the things, the devices, whether that be, again, a phone, a car, a laptop, a desktop, or even in the case of servers as an end node device. And there's three things that we're looking at as sort of how do we start to solve the problem. Step one is we have to start with the device itself. Whether you call it physical device security or enabling hardware trust, we have to use the hardware you have, the technologies that are already available in much of that hardware, to provide trust up the stack. And to leverage that trust to be able to make better decisions about what data and what applications you want to deploy to that hardware. We have to protect the endpoint. And what's interesting about this is that we've all been protecting endpoints for a long time. This is a business that's been around since the 80s. But we have to protect the endpoint based on the kind of device it is. What you do for your laptop and desktop is going to be different from what you do to your phone, and different what you're going to need to do for a control system, as far as the kind of technology that you want to deploy. At the same time, we still need to apply those same security policies and procedures to whatever device it is, regardless of whether it's something that has a nice UI and you carry in your pocket, or it's something that's sitting in the back of a building in the HVAC system. And then finally, we have to also start to look at a novel approach that's really gained momentum in the last couple of years, which is application of functional separation. Keeping the important stuff separate from the not important stuff. Because at the end of the day, it's about the data, and we want to protect the data where it lives. And if we don't take an approach of understanding what parts of the application and what parts of the data need to be protected and what parts don't, we're ending up having to protect too much. And then we run into performance problems, we run into complexity problems, and ultimately security doesn't get done. So by focusing on what you really care about, whether it be the actuator, the control, or the important security or the important keys, allows you to focus on the more easily managed set of the application. I'm sure many of you have heard before, and I'm going to say it again, we have to secure the data. There was an analyst at a conference a couple weeks ago say it's all about the data dummy, and it really is. We have to protect the data at rest, in transit, and in use. And what's interesting is that over the last number of years, we've seen massive innovations in this area. First and foremost, as encryption became prevalent, one of the first challenges was it took too long. It was way too slow on your desktop and your laptop on your phone to do full disk encryption. That isn't the case anymore. And those versions are literally 10 to 15 years old now. The hardware, whatever product you buy, comes on board with acceleration for the math to make encryption easy and not get in the way of application functionality. If you've bought a laptop in the last 5 years, you have that capability today. And most of the operating systems and most of the systems out there take advantage of it. So step one is you want to make sure to take advantage of that hardware features to be able to encrypt the data at rest, to encrypt the data in transit. And we're starting to see now new technologies, ones that we've announced and others. One example is something called software guard extensions that are coming out this year, which allows you to protect data in use, which is really the last mile of the challenge. The other big shift that we have to look at is what we call context-aware security. We have to do authentication access control for the user on that device for that data, as opposed to having access control, okay, we know the user, Maybe we know the device, hopefully we have some understanding of the data, and they're all separate from each other. We have to bring those together and look at them as one functional set and be able to make decisions about where that data goes based on the user and the device that they're on. And then finally, the last piece of the puzzle is really about security monitoring management. We have to make this stuff scale and be deployable and be able to use in a variety of different use cases. And that's applying the right security policies to the right environments, leveraging your event monitoring, and moving towards a notion of connected security so that your network sensors, your endpoint sensors, your policy management, your system event management functions are all talking to each other so that you can actually get to threat intelligence and make real-time decisions so that we can stop the next round of these cyber threats, both on the devices that you use in your cars and in your house, as well as the ones in control systems and on ships and planes. Thank you.
Thank you. And now we'll go back to Mike. I'm told we're all fixed up.
Looks like we're fixed up. Do I need to advance from here, or you're still queuing it up? Okay. So I'm Mike Spencer, Deputy Chief Engineer at SPAWAR, as Admiral Lewis said. I'm very pleased to be here and speak at ASNE, and thank you for inviting me here. I'm going to frame things up along the context of what some of the cyber challenges are. I won't repeat what my colleague already went through, and then we'll talk about a holistic approach to how we're going to solve this, and then how SPAWAR is working with the other SysComs to meet this challenge. So I will not talk about the Sony hack or the Anthem data breach, but I think what's really important is the one about the German steel mill, and that was one where they went in through a phishing expedition. They got somebody in a business system to then, click and get into the network. The folks that got into the network got a foothold. They were able to then maneuver around and go after what the bigger prize was. And they actually, in that particular steel mill, were actually able to take down one of the blast furnaces and do a pretty good amount of damage. That is something comparable to what could happen, between some of our IT networks all the way down to control systems aboard our ships, and that's why we're really concerned with this challenge. So, let's talk about the challenge here with the Navy. Right now, the way we've done things in the past has been very stovepiped in the way we've acquired our systems, but also the way we apply security to our systems. Oftentimes it's either redundant or it doesn't cover all the seams. And the one thing that you have to look at here is that our adversary, while we put things into different enclaves, they look at it as a single network out there that is exploitable, that has threat vectors and a threat surface to it with seams that they like to try to exploit. And that's the area that we're really trying to get at and solve. So it's going to take a more holistic approach. I would tell you this is very similar to the challenge, and those of you that were at the last panel and saw Admiral Dunaway up here, he and I have worked together over the last few years on the challenge of integration and interoperability. I see the cyber challenge as something very similar to what we face in integration and interoperability. It's something that we have to actually bake in up front. So when we look at how we design systems for better interoperability, that's what we're trying to do so that we drive some of those investments up front to do a better job so that we're not paying for all that rework that we see on the back end. Same thing goes with cybersecurity. You don't want to have that as a bolt-on at the end of your development period. As a program manager, I would tell you, I ran into those issues, and it was very frustrating to get down to the end of a test program only to have my test engineer come and tell me, okay, we're going to have to redo the integration test because now we've bolted down all of the security patches in there, and we have to retest everything. And I'm like, you got to be kidding me. So it's a challenge that, you know, I've had to work with over a number of years. I didn't have to work with it when I worked the F-18 program because we didn't even think about those issues, but back in those days. But I would tell you, it's issues that they're dealing with now. So what I'm just trying to say here is that we have to take a more holistic approach to this. We have to look at it end to end with a lot of upfront baked in pieces to that. I keep forgetting to hit the next one. So we talk a little bit about the interface of our IT systems here with industrial controls, and that's a dialogue that we're having, you know, across the SysComs through our tech authority, which I'll get to a slide on that real quick here. But you know, there's certainly differences between how we protect our systems from an IT perspective and how we protect them when we get down to the combat systems or industrial controls. But a lot of those systems are populated with COTS products that, quite frankly, have the same vulnerabilities that you would see in today's IT systems. So while there might be some differences in how we do the protection, the vulnerabilities are still there and are ones that we're going to have to look at a common way and a holistic way, again, of how we approach that. And so that's a challenge that we have, and what I want to do is then go to the next slide here and just talk about the anatomy of attack. You know, if you look at what happened at that German steel mill, where, you know, they got in, they got a foothold, they were able to maneuver around and find, you know, where those seams were, and then execute all the way out there through step 8. It kind of tells you that you need to have those vectors down there where I talk about protect, detect, and respond. You know, we put a lot of resources right now against the protect piece because that's, you know, that's where our kind of knowledge is around how we've tried to do all of this in the past. But really what we're going to end up spending a lot more time on is how we're detecting, how we're seeing how that adversary is maneuvering around once we find them, and then trying to make sure that we have the tools and the training in place to know how to adequately respond to those threats once they are in our network and eventually get them out. So this is, so what are we doing about it? You know, in late 2012, we put together a team of folks that looked at both the logical and physical interfaces between our systems as they go across the systems for the SysComs. But at that same time, we also wanted to take a look at, you know, how security is looked at across those interfaces as we were trying to establish boundaries around technical authority. And, you know, Decoy kind of alluded to it. Not all of our engagements have been that friendly, and we had to, you know, work through a lot of storming and norming that you normally have to do when you're talking about who has technical authority over different systems or interfaces or even the information assurance piece. And so we worked through a 180-day study that was signed out by the SysCom commanders back in June of 2013. And basically, it laid out a plan for how we were going to attack this issue, both from logical and physical interfaces, as well as taking a look at the information assurance piece. And so there's some definitions there that become very important, and that's why it took 180 days to, you know, get to some of these definitions. But I would tell you, it's driving some pretty good behavior and cooperation across the SysComs right now. So we talk about SysCom Tech Authority. That's the tech authority that the SysComs have inside of the boxes themselves that they're producing. You have the IT Tech Authority that really looks at the interfaces that go between those systems and to the gig. And then overall, we have an information assurance tech authority that takes a look at how we're looking at cybersecurity information assurance for all of those systems. And so one of the things that then came out of that is this technical authority board, which provides the governance and the oversight for how we work across those SysComs. There's working groups on both the information technology and the information assurance pieces of that. And we're coming up with the standards, working across the SysComs to help the programs. I think there was a discussion earlier about how we get those into the contracts for future development efforts, as well as ongoing development efforts, in order for the programs to make sure that they're meeting those standards, and then looking at putting the right security pieces in place. And so we've made some progress. There's quite a few standards that have been put into place, the big one being the DFIA, the Defense in Depth Functional Implementation Architecture. And that's going to really serve as, laying out those layers of protection that both the programs can inherit from the networks, as well as guiding them on their acquisitions. We have several interface control documents that we've already developed, and that helps us, again, characterize what the baselines are that are out there, because in characterizing those baselines, it really then helps us start looking towards what we need to do for future architectures, which, again, I think that's going to really help us on that front end and baking things in right on the front end. The Admiral in the last panel talked about how we are converging on having less variance out there. Canes is one of those pieces that helps us do that on the afloat side from the SPAWAR portfolio. And that's a framework then you can build on, and then make sure that, again, you're looking at smaller number of threat vectors that we would be having to deal with. And so in summary, no one is immune to these cyber threats. After hearing what the Admiral said, I think I'm going to go back to my '65 Mustang that I had back in high school, because that's pretty terrifying, thinking what could happen. We definitely need to move towards that holistic approach that I talked about. And this is a team sport. We are working cross-SysCom on this to make this happen. It's not going to just happen from an individual organization. It's going to be the cooperation that we have across the engineering groups. And I would tell you, I'll give some credit to Decoy Dunaway in starting some of this process with the I&I. That really helped the engineering groups across NAVC, NAVAIR, and SPAWAR really get together to start solving some of the tough problems. That's expanded into the cybersecurity challenge, and I think we're going to succeed based on the cooperation that I'm seeing across the enterprise. And that's it, sir.
Thank you very much.
Marv, you can use that one.
And last, Dr. Langston. Sir.
Okay. Oh, I guess I got control. So first of all, let me thank you for having me here at ASNE. I was just recalling that the last time I spoke at ASNE was in the early '80s, so that makes me a little older than a lot of people in the audience. There was a professor, Albert Bartlett, at the University of Colorado, who wrote a book 15 years ago or so that explains that human beings do not understand exponential functions. Now, we as engineers, of course, are taught about the exponential compounding mathematics that we all deal with in almost everything we do, and we, of course, think about them and hope that our financial accounts compound exponentially nicely. But what we fail to really understand is what truly is happening to us, because Truly, our brains think linearly, even though we can sort of intellectually think about the exponential functions. So here's a couple of examples. This nice new phone I have, a Nexus 6 phone right here. When I entered Navy postgraduate school in 1976, the Cray 1 computer was just being designed and released at 80, it could process 80 million computer flops per second. That was the fastest computer on the planet at the time. Several large organizations they were in a bidding war to buy that computer for $8 million in those days. I'm sure that Dr. Skolnick was using that computer to design his laser technology. When I entered NAVC in my second NAVC tour in 1981-82, the Cray 2 computer was put on the market. The Cray 2 computer could operate at 1.9 billion flops per second. So it had gone in those few years from 80 million to 1.9 billion. Every one of the smartphones you all carry around in your pocket today runs at 1.9 billion operations per second. This one actually runs at about 5 times that because it has four processors in it as opposed to 1. So if you think about that, the fastest computer on the planet in 1982, we all carry around. In those days, it required a warehouse full of space. It required massive generators to provide power and cooling to run those computers. Today, we run them on our batteries that last all day. And not only that, we're using flat panel displays that we didn't have in those days. The flat panel displays came along much later and, of course, led the transformation that we all live with in our houses every day. So the slide that I have up there is about a futurist named Ray Kurzweil, you may have heard of. He now works at Google. He predicted back in the 2000 time frame what he calls the singularity. And we all know mathematically the singularity is when the functions go infinite or disconnected and we don't know what to do with them. He's predicting that in the 2045 time frame, there will be a disconnect in the human machine history of the planet, and it'll be much different because of the rapid growth of technology. And if you follow those curves up there, it's hard to see them, I know. He's basically saying that in about the 2024 time frame, a $1,000 computer processor will operate at 10 teraflops per second, which is about the same number of cells we have in our brain. Therefore, the computer processor is going to start to approach the power of our brains. And by 2045 time frame, it's going to be for $1,000 the equivalent of the entire human race's brain power. So that's hard to get your mind around. You can't understand what that may or may not mean. And of course, we all hope that robots are going to be friendly when they get out to that point. And we all know if we look around at what's going on today that robots are replacing many, many functions around us. You know, the whole thing we're living with right now since the decline in our economy in the 6 and 7 and 8 time frame hasn't returned the jobs to the market, at least not the kind of long-term, high-quality jobs that everybody would hope that they have. And a lot of the reason for that is because robots or automation is filling in the holes in many organizations. They prefer to provide automation as opposed to employment for people. And we're all going to be living with that, and many people talk about the coming jobs war associated with that. So the other thing that Ray Kurzweil predicted in a book that he wrote in the 90s was that by 2009, communications and computation would be a dominant military capability, and the side that maintains its resources the best would dominate the battlefield. Sounds kind of familiar, doesn't it? It's not until our senior 4-stars have started to realize that this is not just about losing a network or losing the information that's on somebody's screen. It's potentially about losing the ability to effectively use our weapons, use our military, use our ships the way we want to use them. And that's why we have TIFCA. That's why this cybersecurity stuff is not just a joke. It's a big deal. So a little bit more about cybersecurity. If any of you haven't seen it or would like to look at it, the Defense Science Board did 2 studies that came out in January of 2013. Anybody can look at them. The whole world is open to access these on the Defense Science Board website. And these 2 reports, as you can see, let's see what those names are. One of them is about cybersecurity reliability in a cloud, and the other is about resilient military systems and the advanced cyber threat. It says straight out in the document, the second one I quoted there, that if we went to war today with a peer competitor, we would not dominate the war. That's a hard thing to say, but those guys said it. That's what they believe. Now, the thing I like about what the DSB did is in that triangle that's shown there. What they really do is they break down this cyber threat that we all talk about in sort of a massive global context into the three components of what it is. The tier 1 and 2 layer, that bottom layer, is the people that are spending thousands of dollars and going in and buying hacker tools off the web and coming in and messing around with your computer, my computer, or somebody else's computer. That's easy to do. For $100 today, you can buy a hardware password cracker that will crack any password up to 12 bits within a few minutes. And for passwords, by the way, that are less than that, software password breakers can break them in less time. In the tier 3 and 4 layer there, that's people that are spending millions of dollars to be serious about this game. Those are criminals, those are organizations that want to get into the business and want to do more serious things, and I'm sure some of what we've been seeing that Steve already mentioned is part of that group of people. The people that we worry about, though, for the military side is the tier 5 and 6 threat, those top guys. They're the guys spending billions of dollars. They're the people that are, like us, taking this game so seriously that we're going all the way from not just inventing and creating new exploits, but we're also planting inside threats into the systems. Likewise, they're doing the same thing to us. So that's the reason the Defense Science Board says this is serious enough that we have to do more about it. You may know that IBM sold its laptop business to a Chinese company named Lenovo over the past couple of years. You might also know that the Lenovo laptops that were being purchased back through GSA and the government were discovered to have embedded malware in them that could pull back off those laptops secure passwords and other information to be passed back into the network to those that were trying to receive that information. You may know that the current Navy CANES program, which is our consolidated network enterprise system that we're now fielding on our ships, uses IBM Blade servers, as does the Zumwalt ship uses IBM Blade servers. And you may know that the IBM Blade server business was sold by IBM to Lenovo this last year. And therefore, all the maintenance of all those Blade servers have gone to Lenovo already. IBM is done with that business. So obviously we have a problem of passing that design criteria and moving ourselves beyond that situation, and it comes back onto the acquisition system. I'll talk a little bit out further. Let me ask you one other thing. How many people out here have heard of the company Huawei? So 1, 2 people, 3 people? Huawei is currently the largest telco provider on the planet. Huawei is the largest provider of fiber optic telecommunication equipment and 4th generation wireless equipment. Huawei has 64,000 engineers working full-time on all the designs that they do. Huawei, to become an engineer in Huawei, you have to go to a Huawei university as an unaccompanied tour for 12 months before you can even enter the engineering business in Huawei. Huawei was started by Ren Fenzhui, who is a Chinese equivalent of an NSA officer. He started the company 25, 30 years ago, and it has grown dramatically since then. But the intellectual property that Huawei started with was not Chinese intellectual property. It was the intellectual property of Motorola and Cisco and various other companies that you can still find in their code today if you look at their code today. There's only one country on the planet that's not buying Huawei gear in their telco systems. That's the United States. The only reason that is because the United States government has told the telco providers that if they buy that gear, they're going to quit giving them government contracts. So it's only a matter of time before we're going to have Huawei in all of our systems. And if you wanted to be in the information business on the planet, wouldn't it be a nice thing to have control of all the telecommunication equipment on the planet? That's the situation we're in, and that's what's happening. So what are we going to do to reverse these trends? Now, this chart is a chart that I put together several years ago now, and you'll recognize those curves as technology maturity curves. So a technology, or S-curve as we often call them, really represents how it takes a long time to invent technology and start to mature it, and as it gets recognize and people understand the value of it, they start buying it rapidly, which is the more vertical part of the curve. And then as that technology becomes old and less valuable compared to newer technologies, it starts to trail off. It's easy to think about some of those things in our lives. The PC computer is an easy one that has come in that vein. Almost all of us have a flat panel display in our houses today. It took us 30 plus years to invent those displays, but after they got recognized and produced at a low enough cost, we all bought them. And of course now we're probably looking at buying the 4,000 line flat panels that are turning our televisions into almost 3D viewing televisions. It's phenomenal technology. So in the computer business, as I've depicted up there, we've sort of gone through 3 waves of technology, families of technology, because it's way more than just one kind of technology. And it turns out that since this chart was put together, we're really in the 4th wave of technology, and I'll talk a little bit about that. The problem we've got, though, as I say up there, is we're trying to acquire 3rd and 4th wave information technology with 2nd wave policy and acquisition controls. We're trying to do what Vic was saying earlier, buy systems that take us 10 years to buy it when the technology is turning over several times. In the Keynes of the Keynes system, which is now out on about 40 ships on its way to 200 ships, that system has already got end-of-life hardware and software problems in it. That system is 5 generations of information technology old, and unfortunately, older technology is more vulnerable to cybersecurity threats. So we have the issue to deal with in that sense as well. So one of the things that I've recommended to various seniors that we could start to do differently, and this goes back to my own history. I was involved as a young engineering duty officer with the information instruction set architecture of the UC-43 computers. That's back in the days when the Navy built its own computers, which actually you could argue is a good thing nowadays because there's not a lot of hacking tools out for those computers. I was also involved in the NAVSEA business when the Navy Research Advisory Committee recommended that we require that the military systems had to get a waiver to use military spec gear, and then as opposed to using commercial gear, because that's when we started transforming ourselves over to commercial gear. And you may or may not know that the early first Tomahawk systems were the first systems that used commercial technology that was ruggedized. So now we find ourselves in a situation where the big guys like Google and Amazon and Oracle and others, they actually don't use commercial off-the-shelf equipment. They do use commercial off-the-shelf equipment that's modified. They modify the cards, they modify the commercial operating systems, they modify the network systems. So they basically make a proprietary infrastructure up through until you get to their API level of interface to those systems. The reason they do it is because of the cyber threats that we're talking about. Google currently supports 800 million Gmail users a day. That's massive scale. And that's why those guys spend so much money, as Vic was pointing out, to deal with the problem. So I think it's time for the Navy to take a different look at this system, at these IT systems and the way we treat them. One way we could do that is we could pull them out of the ship main system, we could pull them off the ships, we could maintain them and build them and upgrade them in warehouses or in facilities in our laboratories. And we could then provide a refresh of that hardware and software to those ships every time a ship was doing workup and deployments. And even if they kept all the computers on the ships the full time until they go into their large overhauls, we could always give them a physical replacement by just walking out and putting in new drawers or delivering a shipping container of some kind that contained all the computers and provided that computer's gear. And in the process, what we could do is we could get away from the multiple baselines that the Keynes program is struggling with, and we could have pretty close to one baseline, because you could take virtual desktop technology and have the schoolhouses come into the warehouse and talk to those systems. You could have the same thing for the sailors that were in their large overhauls, talking to their same systems, and it would be virtually unknowable to them that they were talking to the shore computers versus the computers on their ship. And then to maintain the ship's autonomy, we could put those new upgraded hardware systems out on the ships, and we can continue to upgrade software as we go forward. So we have to do something different in order to pace the cyber threat, in order to use this technology to its best advantage. One of the things that Dr. Zangardi, I like to kid him about all the time, and it's true of Mr. Halverson in the DODC office, CIO office as well, is they often talk about the need to reduce the cost of IT so we can buy more warfare capability, more systems and weapons. Well, that's a good thought unless you realize that the IT systems can obviate your warfare systems. So my argument is we need to spend more money on IT. We need to increase this IT budget and increase the way we do it, increase the speed of refreshment on these systems until we actually truly have a hold of this cybersecurity threat problem that we're dealing with. You know, we don't talk about it, but the reality is we've been in a cyber war since the late 90s. The military departments across the Army, Navy, Air Force have been being attacked, and we're dealing with those attacks all the time. Because they're not physical attacks and we don't have to treat them as an act of war, in fact, we're having debates about whether or not it's an act of war right now, these cyber war activities are continuing forward, and it's, as we've been talking about, getting to the point where we have to do something seriously more about it. So that's all I have to say. That wraps up my comments, and thank you for listening.
Thank you, Bob. So that concludes the panel. I'm open to questions. If you don't have any, I have some.
First of all,
They, okay, good. Okay.
you can probably, I know you can hear me. Thank you to the panel. Interesting discussions. And clearly we're naval engineers and focused on Navy, ships, airplanes and all. But I'm really curious, with all the effort that's ongoing in the Navy, DOD, to what level is our civilian infrastructure, be it communications, electrical grids, and the many, many others? I mean, we hear a lot about that, but is our Navy team and our DOD team being asked for what you're doing? Because I suspect, as always, we're way ahead. Because clearly, if we solve our Navy problem but lose the national cybersecurity problem, we haven't won the war.
Steve, maybe if you could address that from the civilian side.
So there is multiple areas of collaboration between both DoD and industry and the larger critical infrastructure, both on information sharing, so that as threats are coming into one, that we're sharing them across. And it's been ad hoc for a number of years, and it's being more formalized as we move forward. We've had, there've been information in ISACs for various different industries, but it's even getting better with some of the new cybersecurity framework that was announced recently at the event a couple of weeks ago. At the same time, because at the end of the day, whether it be a ship or the power grid or the data center of Google, and some people will consider Google critical infrastructure, because if you don't get your email, that's the end of the world. Because we're at the end of the day, a lot of the infrastructure we're using is COTS. It's applying best practices between the two different organs. There's been a lot of information sharing, not just on the threat side, but also on the best practices about how to deploy security technologies, doing proof of concepts on sort of addressing the newer threats, and sharing that information. One of the things that it may not be as public, but the DoD spends a lot of time in the Bay Area, and they go talk to the large infrastructure companies about how they protect their systems, and vice versa. The Amazons and Googles come out here. And so there's a lot of information sharing, and I think that's the basis for how do we get to make sure that if we can protect the ships, we still need to protect the power grids. The challenge is that the folks here have a mandate: thou shalt protect the ship and make sure that it runs. When you get into the larger critical infrastructure, there are a lot more moving parts, individual organizations. So it's taken a little bit more cat herding to get to the same level of protection that you may have in an individual program within the Navy, but it is coming. At the same time, I think one of the things that I've seen from an industry side is working with our partners in DoD and specifically in the Navy as well on solving some of the critical infrastructure problems. To give you an example, we've worked with several DoD folks on a solution that uses both hardware and software to provide industrial control protection, using application whitelisting, hardware trust, have deployed that around currently I think it's 80 Air Force bases and about 200 bases total. And then we just recently demonstrated that for one of the power grids down in Texas. So using that same capability that we use to protect the control systems for DoD and working with the larger power grids and nuclear facilities and the like to use that same concept of technologies to solve their problems, because they really are a lot the same problems. So seeing that, the correlation of the Army and the Navy and Air Force leading the way for industry to be able to protect themselves as well. And it's been exciting times because I like to see that the DoD is leading the way again.
So, Marv?
Great question, Dave. I recently was listening to Admiral Denny McGinn, who, as you know, is the Navy's Assistant Secretary for Energy Systems, and I asked him, what do we do about making sure that the energy being provided to us by these commercial providers is actually being protected in some way? And he said, great question, we're working on it. So it's in fact true. We could be doing everything we want about our cybersecurity and still lose the power that comes to us because we don't often produce our own power as a backup for many of our bases. I will tell you that when I was in the DoD job as the DEP CIO, that was during the Y2K period of time. And that Y2K period of time was actually many people poo-poo it as a silly thing, but it was a bell ringer for the nation. It did several things. We worked at the federal government level across all sectors, power sectors, financial sectors, every sector, to make sure that everybody was trying to address that problem. And it actually became the bell ringer that created the DHS, the Homeland Security Department. The other thing that I often tell people is when 9/11 happened and we lost the Wall Street capability, that came up quickly because the Y2K had caused everybody to review their contingency plans to do something about them. So we definitely have to treat all of these problems across the full end-to-end solution, as Spence was talking about, but even end-to-end to everything we do, from the power all the way up to when we're using it.
And one other point, there are some really good documents that have been put out. Critical information, infrastructure protection has got several papers and guidance for the broader industry of how to adopt a common set of best practices. DHA put out something about 2 years ago, I think, if I remember correctly, that gave a detailed list of best practices for everything from power grid to financial systems to the internet providers, so that we have a common set of baseline practices about how to protect the infrastructure, so that we don't have different organizations doing different things, and therefore it makes it really hard to assess whether or not the power grid that's servicing a particular Navy grid base is doing the best practices it is. So by having that common set has also helped a lot.
Okay, excellent. Thank you.
Afternoon, sir. Continuing the thread of collaboration between civilian and military practices, President Obama recently announced an initiative, I think, Mr. Orrin, you were talking about that, to share information. And there's been a lot of discussion in the news of Facebook's competing threat exchange website, which is maybe an alternative that doesn't involve the government. I'm curious if any of the panelists have opinions on how, if that plays out to not involve the government, what effect does that have on us in the Navy?
Victor, do you know anything?
Sure, I'll take a shot at that. It kind of goes to the same line of some things we were talking about earlier when it comes to that relationship between government and industry. One of my old mentors once told me that there are lessons learned in failure. Whenever you fail, whenever there's a hack out there, there's information that's out that's available for the entire enterprise, for the entire nation to learn from that. I think what the president is trying to get to, and what a lot of people on this panel have talked about, is how do we get folks to share those lessons that to better us all. Unique challenge when you're talking about a for-profit industry. If you're a for-profit industry, let's take Target, for example. If you recall the Target hack, I contend that the day after that Target hack was announced, if you drove by a Target store, you would probably see fewer and fewer cars in that store on that day. The good news is, if you drive by a Target store today, thank God our memories are short. We are back. They would say that has less of effect. And I think until we all, industry side as well as government, get used to the fact, and not just get used to it, but accept the fact that hacks are going to happen. I think the number you threw out is 85% of the companies have been hacked today, and there are those, FBI said the same thing, that there are those that have been hacked, and then there are those that don't know they've been hacked. So once we become comfortable with that, I think what you'll see is an increase in that sharing, the increase in that knowledge learning across the board, and I think that truly is the on-ramp to the solution to this broader problem.
Can I just add one comment? I happen to have neighbors across the street from my house in San Diego that work for Sony Gaming, and they were hacked, if you remember, about 8 or 9 months ago, which shut them down for a month, and all the employees in that facility were out of work for that period of time, and then they got recently hacked again. I just found out last week that Sony sold the Sony Gaming to another company for $0. $0. The only thing that they had to pay for was they had to pay for the employee compensation associated with severance packages, et cetera, which cost them a few $1 million. But in essence, that hacking process has brought that piece of that company to its knees. So it's just an amazing situation.
So I think, just to finish off on it, there's going to, NIST, DHS, and Intel recently published a white paper how we've adopted internally the framework. We're going to see more of that as industry and the government come together to show how the framework actually helps both industry, government, and the individual consumer that are using services from those organizations or being protected by those organizations. So look to see more there, and whether or not, you're going to continue to see the Facebooks and others want to do a slightly different thing, but they're not doing it in a proprietary way that it's closed. So it's still goodness that Facebook's going to have its own vulnerability disclosure website, because still everyone's going to take advantage of that. So it's not a bad thing per se.
Okay, thank you. Admiral, how are you?
Hey, I'm doing fine, Dave. And I really appreciate your analogies comparing a person living in the basement that you don't know about. I think that's a very apropos way to describe things in a way that people can understand it and make sense of it. My question is there's in some of the slides there you talk about protect, detect if somebody breaks through, next respond to that threat and deal with it so that it doesn't cause any more harm than it already has. I would offer that there's a fourth element to it, and it certainly applies to any crime that's committed, which is the deterrence of some certainty of prosecution at the end of it. So the question is these systems as they are, and you've described this three-tier approach, is there things in place that operate in a kind of forensic way that would allow you to have the equivalent of fingerprinting, you name your criminal evidence gathering methodology, so that all of those kind of, some cases, vandalism hacks, as well as obviously organized for money or for national interest, that you can almost for sure follow the trail back and identify the perpetrator, and then start to exact some sort of accountability that would then perhaps act as a deterrence for future vulnerabilities.
Okay. I think I'd prefer the government guys not answer that question.
So the simple answer, and unfortunately it is a simple answer, attribution is really, really hard. And there's a variety of reasons for that. Whether it be in the malware, the fact of the matter is almost never is malware completely unique. They typically use families of other people's stuff. They maybe make some modifications. So when you go look at, for instance, the forensics data, how do you know that it was that piece of malware from a particular actor, or the fact that they just sold it to somebody else, or somebody else took someone else's malware and copied it? The other is that very rarely do you find direct attacks. Because if I attack you, you're going to figure out that it's my IP address. So I'm going to hack somebody else first, put my malware there, and have it hack you. And maybe I'm going to do that 12 or 13 times. And so attribution becomes really hard from a legal perspective, just from the forensic side, of knowing, is this malware unique or a part of a family that it's existed, and is it cobbled together, Frankenstein, from multiple parts? And is it that country attacking me, or that organization attacking me, or are they just being the dupe that's been used to do that for them? The flip side also is the legal frameworks just aren't there. So let's say you did get total attribution. You know who wrote the malware, you could trace it to their IP address, but they're not in the United States. And let's say they're not in a country that has a really good legal relationship with the United States, which many of these hackers, that's where they live. The legal ability for you to go after them is going to be very limited. So from an industry side, the attribution and response on that side, it's really, really hard for a company to do much more than to work with federal law enforcement and the broader DHS and DOJ to work on sort of collecting the right information, getting the right information in the right hands so that somebody at some point can make a decision, but it's not going to be something that individual organizations today can really do a whole lot about other than protecting themselves. One thing that you'll see, there's been a lot of debate, I'll give an example. If a certain bank was hacked and then that hack was used to attack another bank, And it's found that if that first bank didn't do industry due care to protect themselves, there's liability discussions. This is a big debate in the legal realms of, can I sue you because you were used to attack me even though you weren't the perpetrator? The courts are still working on that one.
Okay, thank you.
Thank you.
Sir?
I know there's a certifying process for Navy systems for cyber and information assurance. Is it also going into the operational test? Is this something OPTEP for, and is it going into TEMP, so those requirements getting written into those?
I can answer
Okay,
that.
Mike?
Yeah, and talking to Zoil Penfield, one of the things that they're looking at is including cybersecurity as part of their operational test scenarios that will be introduced in upcoming operational tests. I was thinking about one other thing on that, but that is right now where he is headed on that, and I haven't seen much more than the outline of what he's trying to do on that.
So I expand on that. I mean, in order to test, kind of have to test to a standard.
Yep.
And Mike talked about where we are in standards promulgation. So we're moving as fast as we can and that in a cooperative, collaborative way with the other SysComs to define those standards. Obviously, the current systems and the current systems under development weren't developed in accordance with those standards. So there's a time period of probably a long time before we start seeing the first systems that come out that are in accordance with the standards. So then we're sort of in a glue-on environment or a patch-in kind of environment. So there's we have several years, I think, of working through that dynamic, and I think that's just the way it is.
Right.
Okay.
So-
Sorry. Oh, sorry. Go
So
ahead.
if I could add just one more thing to that. As you guys know, the current OPTEP for testing scenario is a product-based testing scenario. You have your requirements, you test to that product, you test the way that product's designed. As we've discussed here, this is a very dynamic area. So by the time you test that product, the world has changed. So I think one of the things we have to struggle with is, should that testing framework, especially from a cyber perspective, become more process compliant, as opposed to your compliance to the process of change, your ability to adapt to that, as opposed to a singular focus on the cyber, your ability to address the cyber threat of that day. So I think there's a lot more to be done in that area.
Yeah, and Victor just reminded me of what I was thinking about before. The setter review process that we use in engineering that takes you from, requirements analysis all the way through the test phase. One of the things that we are looking at, because that setter review process has been focused on systems, individual systems in the past, from our I&I work and now with the cybersecurity work that we're doing, we see the need for a more holistic approach to how we do those reviews and how we look at how systems work together. And so introducing at the setter reviews the right kind of key questions, the right kind of metrics that we're going to be, measuring ourselves against are going to be the things that will prepare us ultimately for those tests that we'll be doing downstream.
Let me just add to that a little bit. I sort of like to be cantankerous about this. I think what we do is totally ineffective. I think it's a waste of time. I think it causes us more harm than it helps. And the reason is because all of our red teams go in and they look into our systems and they use cheap hacker tools and they break into the system and they say, yep, you guys aren't secure. So if these processes were very good, we would be secure. So we have to turn it around. We have to get on the other side of it. We have to have proactive, continuous testing mechanisms that always monitor our software, make sure that from day to day or hour to hour, nothing changed in that software or in that system to make it vulnerable. And we can't rely on the sailors who don't have enough time or expertise or training to be putting in all the changes that are required all the time, because these processes are points in time. So if you get an ATO to operate, authority to operate, we don't look back at that system for another 4 or 5 years. And the day after the authority to operate was put in place, we could be hacked or we might not update the system. So the process is useless right now, in my opinion.
And in fact, that's what we're doing. We're accelerating deployment of those kinds of tools onto our systems. Yes, sir.
Good morning, Admiral. Good morning, gentlemen. First, I wanted to throw a plug out there, Admiral, for one of the books on your reading list, Worm,
Yeah.
which I think outlines some of the difficulties that Mr. Oren talked about related to attribution. And it's a great read. My copy got sucked into the community I'm working in now. I can't find it, but I thought it was a good book to pass around. Related to this, related to the testing question, and Dr. Langston, some of the things you mentioned related to trying to pull forward and get newer technology out there within our 30-year platforms. One of the problems, and I think we've touched on already a little bit, was testing. Spoke recently with Dr. Crossway, and he mentioned that with respect to cybersecurity, that some of the things we do, such as ITTs and ATOs, aren't really as effective in addressing these cybersecurity issues. You have a pile of paper that doesn't really do that much for you. His suggestion was use red and blue teams to explore vulnerabilities. Now, we're not going to get them all, and even if you're doing agile versus waterfall type testing, that you're still going to have some, but I think it sounds like you might have a better opportunity to do that. And the turnaround time is a real factor. They're moving at a much faster pace than we are, and when it takes years to get a new system on the ship,
Yes.
we're way behind the time. So if the team or the panel could talk about that, I'd hear that. Thank you.
Can I just comment on Google for a second? It's interesting. Google hires the best hackers they can find on the planet to run a hacker team of their own that's continuously looking at their system because of the reasons we've talked about. But they also offer a $3 million award for anybody on the planet that can hack into their systems. So far, they haven't really had to give that $3 million to anybody. They've given a few $100,000 to a couple of small break-ins in their system, but basically they're saying, come and get me, and they don't care if it's us, the government, or other hackers anywhere.
Two questions. Sorry. How you doing?
Good morning, Albert Lewis. Good to see you, gentlemen. Thanks very much. You've done a great job of characterizing the holistic approach to cybersecurity from a technology perspective, in some cases policy. Two other elements you actually touched on in your comments were the supply chain management aspect of this and the insider threat. So we're in the midst of now the cyber awakening, an increased awareness. When you consider those other elements, is there any thought to expanded collaboration, not only among the SysComs, but also the schoolhouses and even the investigative agencies to tackle it from a holistic perspective and tie those other pieces in?
Anybody want to take that? I think the answer is yes, and we might be reluctant to talk about it.
Well, I would just add on the supply chain side of it, we're working with companies right now that do build their computers in the country and can, for a 20 to 30% premium, provide completely insourced, U.S. insourced chips throughout the whole system. So we have the ability to control the supply chain. It's tough. We haven't worked on it as much as we need to. There's a lot of serious examples where we know that the supply chain has been breached and where we have had to back our way out of that situation, and we probably have examples where we don't know it, but it's a serious part of the problem and it has to be addressed.
So if I can add one comment to that, it's and supply chain has been a topic, a hot topic for some time with the DoD. I think one of the biggest challenges, at the end of the day, is when you do have a solution, whether it's from particular companies or is translating that importance to the acquisition side. So it's great to talk about and yell and scream that we need a better supply chain, we need US, we need verification. But if it doesn't reflect into the requirements and into the budgets that are going to go buy those systems, you're not going to get it. So just saying you want it isn't good enough. You have to build that into the requirements, but with an understanding of what's actually feasible. You can't just say, well, we want everything to be built in the shores of the US from start to finish, because you're not going to get a system. But understanding what are the critical components that you want to have control of your supply chain and building the requirements appropriately for that supply chain into the RFPs, into the BAAs and the like, is how you will get there. But you've got to link the budget, link the acquisitions, and do it in a smart way, because there's always that knee-jerk reaction, which is, oh, we're going to go all GOTS again. And then you're back to square one, and you're not going to get the systems you need either.
Excellent. Sir, last question.
Gentlemen, thank you all for your time. I found this pretty intriguing. It's a very difficult problem, actually. We're going to have trouble solving the next several years. But my question, you've hinted at it a little bit, and we've talked about machinery control, ship control, component level vulnerabilities. Can you provide any insight into what we're actually going to be doing Navy-wide for systems that already exist, backfit, and implementation in other component level equipment, just small motor controllers, PLCs, or do we expect something to obviate the need for that kind of policy?
So I can take a shot at that. You know, I mentioned as part of my briefing, you know, the ICD work that we're doing as well as the standards work. We're really trying to characterize what that baseline is out there so that we know where the vulnerabilities are, we know where the threat vectors are, and in fact, you know, the information that we're pulling together right now is so critical that we're pulling it over to the secure side. We're not doing any of that interface design document work over on the unclassed side anymore. That has all been pulled over, which is causing us some muscle movements that we're having to do back at SPAWAR and moving some of our people who had a desktop computer in an unclassed space now working over in a classified space to do this work. So, you know, again, most of our ships out there right now have a whole lot of legacy things on there that present a threat surface that the adversary can, you know, to try to maneuver in. And so we're seriously going in and working the cross-SysCom effort to do that.
Yeah, I guess I'd say from the ship integration perspective, we hear the drums, we hear the noise, but it's far away and we don't know what it means yet. So
We're working hard to get it closer, I'll give you that.
Yeah.
Let me just add to that a little bit. So I've been working with a company in San Diego, and they've been working for a grant from the Department of Energy and working with Southern Cal Edison, and they have actually come up with a pretty interesting way to go back and put encryption certificates on each SCADA device in the system and then feed a back channel control signal out of that SCADA device. So it does two things when they do that. Number one, it is backfittable. Number two, it makes sure that they know that everything on the network is something that they provide a cert to, because if it doesn't have a cert, it can't do anything. If it does have a cert, they know it. They know it's there. And then the other thing they can do with the back channel is they can control each one of those SCADA devices to either reboot it, reflash the firmware, or do other things to it. So there's other companies working on the same kinds of things, but these technologies need to get fit back into our control systems in our ships and airplanes quickly.
Good. Thank you very much. Excellent question.
Thank you.
All right. So that concludes the session. I proclaim you all now card-carrying members, charter members of the ASNE Cyber Elite. Okay. So I'd ask you to tell everybody what a great panel they missed, and a round of applause for our panelists. Thank you.